everyone from Virginia on the East Coast, coming to you live from Rocket Lab Launch Complex 2 on the eastern seaboard as we count down to the launch of our first Electron mission from our launch pad on Wallops Island, Virginia. You are looking at our Electron launch vehicle vertical and ready for liftoff from the NASA Wallops flight facility near Chincoteague. My name is Muriel Baker. Thank you for joining us for today's mission, our 33rd launch of Electron, but our first flight of our rocket from here in Virginia, scheduled to launch in under an hour's time at 6 p.m. Eastern Time.
And my name is Jane McNichol. I'm a mission manager here at Rocket Lab. And along with Muriel, we'll be taking you through today's launch attempt for this mission for our customer, Hawkeye 360. We're starting off the new year with this first launch from Launch Complex 2 after standing down from our last attempt a few days before Christmas due to strong winds. The weather today, though, is cooperating, and we are on track for an on-time liftoff this evening. Our launch operations team here at the pad and our launch control center at Wallops have powered through preparations for today's flight. The range is ready, the rocket is ready, and Hawkeye's 360 satellites on board Electron are healthy and waiting for their ride to space. Once they're delivered to orbit, they'll join the rest of Hawkeye's constellation to detect and monitor radio frequency signals around the world, which Hawkeye 360 used to provide geospatial insights to their global customers. Here's the team to tell you a bit more about their mission.
Hawkeye 360 is engineering a new kind of vision with satellite clusters that identify and geolocate RF signals, penetrating this hidden realm of human activity, activating RF's full potential in pursuit of a safer world, detecting illegal mining in Niger, monitoring dark ships around the Senkaku Islands, tracking GPS interference in Ukraine, identifying oil smugglers near Iran. The launch of Cluster 6 marks a major milestone. These new satellites will adopt a mid-latitude orbit, boosting coverage of regions along the equator for expanded RF frequencies and optimized data collection, all making for greater global insights. It's our first collaboration with Rocket Lab from their brand new launch complex on Wallops Island, and our first launch from our home state of Virginia, representing a major win for Virginia's flourishing space-based economy. With this launch, we continue to expand on our mission, further accelerating mission-critical data and revisit rates, and providing better domain awareness through RF datasets, so analysts have the best tools to make the world a safer place.
We're honored to not only be Hawkeye's ride to space today, but also in the year ahead, with 2 more launches for Hawkeye 360 scheduled on Electron after tonight's mission.
Altogether, we are set to launch a total of 15 Hawkeye satellites to low Earth orbit between now and 2024. And what's a better way to mark the start of this partnership than with this inaugural mission, carrying their satellites to space from right here in their home state of Virginia. To mark the occasion, celebrate our new home for Electron, and in recognition of our launch partners NASA and Virginia Space here at Wallops, we've given this mission the name Virginia is for Launch Lovers. You can see our Virginia is for Launch Lovers mission patch on your screen there too, right at the top of Electron on the rocket's fairing. Just a few miles away from the launch pad is Rocket Lab's Integration and Control Facility, a building we call the ICF. It's here that our mission team, Hawkeye 360 engineers, and range partners NASA and Mars, or the Mid-Atlantic Regional Spaceport, are monitoring launch pad, launch vehicle, and launch range readiness in the lead up to liftoff. Their next check-in is the T-minus 35-minute status poll, where our launch director, Michael Pearson, will get a weather update and speak with each operator to make sure the schedule is holding for our 6 p.m. Eastern Time launch. We're going to tune into the audio channels now and listen in for the latest.
All stations LD on countdown. Proceeding with the status poll for launch sequence. Stand by for the poll for current and expected status for launch. Please report green or red, tracking green or red for launch. Stage.
Stage is green, tracking green.
Avionics.
Avionics is green, tracking green.
GNC.
GNC is green, tracking green.
VCON.
VCON is green, tracking green.
T1.
T1 is green, tracking green.
GC.
GC is green, tracking green.
PLS.
PLS is green, tracking green.
Mars CE.
Mars CE is green, tracking green.
Mars Ops.
Mars Ops is green, tracking green.
MM.
MM is green, tracking green.
NASA LWO.
LWO is green, tracking green.
NASA GSO.
GSO is green, tracking green.
NASA PM.
NASA PM is green, tracking green.
NASA RSO. NASA TD. NASA RSO LD countdown.
Yeah, NASA RSO is red, tracking green. We will be red until the boat exits our hazard area, but we are expecting it to exit.
Copy, I'll call you on SUP 1 shortly. NASA TD. TD LD countdown.
NASA TD is green, or red, tracking green.
Copy, same reason as RSO.
Yes, sir.
Thank you. And NASA LWO, can you please provide a brief weather brief for T0?
Copy LD, this is LWO on countdown, the T-minus 30-minute weather briefing. Continue to let those upper level winds going to stay about where they are now throughout the countdown into the launch window. Looking at our latest balloons compared to the model, you can see here the latest balloon, the partial was the green, very similar to the forecasted model output for T-minus 0, and direction very similar as well.
There we go. That was a mostly positive update from the Rocket Lab ICF, with most operators with green, tracking green, apart from that boat in the hazard zone. But we are tracking green for them to clear that, which means we will be moving forward with tonight's launch attempt as the clock continues counting down. We are now at T-minus 31 minutes to lift off from Launch Complex 2 for Virginia is for launch lovers. If you're watching from the Pacific Coast, then launch is set for 6 p.m. Eastern Time this evening, and adjust your time zone to that. If you're tuning in internationally, then you can convert launch timing to your local time zone from 2300 Coordinated Universal Time, or UTC.
As we make our way through the countdown, let me take you through a rundown of our Electron launch vehicle next. Electron is a 3-stage launch vehicle that stands 18 meters or 59 feet tall. The black and white stripes you can see here are a visual effect caused by the rocket's liquid oxygen propellant. Frost forms on the outside of the rocket due to the cold temperature of the liquid oxygen inside the rocket's fuel storage tanks. The black comes from Electron's fully carbon composite tank structure, using material that is lightweight yet strong enough to withstand the pressure of launch. Powering the rocket are 9 Rutherford engines on the first stage and a single Rutherford engine on the second stage. These engines are 3D printed and named after the famous physicist Ernest Rutherford. They were the first engines of their kind to reach space, given that before the Rutherford, no other 3D printed electric pump-fed engines had ever crossed the Kármán line to space successfully. The engines use batteries to power the electric motor behind the Rutherford's rotodynamic pump and have the same general structure across the first stage and second stage, apart from a larger expansion nozzle for the second stage engine to better operate in the vacuum of space. We have a unique 11th engine on Electron also, called the Curie engine after chemist and physicist Marie Curie. This propulsion system is located within Electron's third stage at the top of the rocket. This third stage is an orbital transfer vehicle we call the kick stage, which carries the mission's payloads to their exact destination on orbit. The kick stage will carry today's 3 Hawkeye satellites to a 550-kilometer circular orbit after Electron lifts off from the pad at Launch Complex 2 on a southeastern trajectory. From liftoff to orbit, the entire mission tonight should be completed within an hour.
We really are so excited to finally be launching Electron from Launch Complex 2, the first of many exciting missions coming to Virginia. This summer, we'll be launching 4 satellites on 2 back-to-back missions from LC-2 for NASA for their Tropics mission, a program to monitor tropical cyclones and hurricanes that will help scientists better understand them and ultimately help save lives with earlier and more accurate storm warnings and predictions. To be ready in time for this year's Atlantic hurricane season, each pair of these satellites on these 2 missions need to be placed on orbit one after another and within just 60 days. Luckily, we know how to move fast, and alongside Virginia Space, we built Launch Complex 2 in just 11 months as an indication of that speed we can move at. For the majority of last year, we launched Electron every month, and our fastest launch turnaround in 2022 was just 15 days. Electron is well suited for rapid launch, and it's a capability we are excited to bring to Wallops for future missions, not just for NASA, but for any government defense or commercial small satellite mission that wants a streamlined ride to space. Rocket Lab's VP of Launch Systems, Sean DeMello, led the charge to bring Electron to Virginia, and he has more to say about what it took and why it's important to bring responsive and reliable launch to the Eastern Shore.
Hi, my name is Sean DeMello. I'm the Vice President of Launch Systems here at Rocket Lab. Welcome to Launch Complex 2. We selected Wallops as a location for Launch Complex 2 because of its high launch availability, the strong support from our partners in NASA Wallops and Virginia Space, and incredible support from the state of Virginia to bring this new launch capability to the Eastern Shore for the nation. In under 11 months with our partners in Virginia Space, we built Launch Complex 2 that includes all the critical infrastructure to support a launch of Electron. In addition to the launch pad, we've also built the integration and control facility about 8 miles from the launch pad itself. This facility supports parallel processing of multiple electrons, multiple clean rooms for payload processing, as well as houses our mission control team. With Launch Complex 2 now operational, we have enhanced our global launch capability to over 130 launch opportunities per year. This provides small satellites unrivaled flexibility to get to orbit. This launch has been a long time coming. The Rocket Lab team has worked incredibly hard across engineering, operations, safety, regulatory, and compliance to make this all happen. We also have worked hand in hand with our partners in NASA Wallops as well as Virginia Space to make this a reality. So we're looking forward to seeing this rocket lift off.
A huge effort from the entire Rocket Lab team to bring Electron to the Eastern Shore. Checking in on the countdown to launch, and we are now at T-minus 25 minutes to liftoff for Virginia is for launch lovers. Our next check-in point with the launch operators will be the T-minus 12-minute mark when they run through the go, no-go poll to determine whether to carry through to liftoff. So far, all reports from Mission Control, though, are positive, with the range, rocket, weather, and payloads all trending green for launch.
And that clear weather, too, will hopefully mean some good launch viewing opportunities for fans living along the Eastern Shore and watching right here in person in the Chincoteague area. Once Electron is high in the sky, it's possible you'll be able to see it from as far as Georgia in the south, Ohio in the west, and Maine in the north from the T+2 2.5 minute mark after liftoff. If you're here in Wallops, Virginia, or the surrounding areas, the NASA Wallops Visitor Center is one of the best viewing locations just 7 miles back from Launch Complex 2. And if you'd rather stay warm and inside, we'll of course have all of the best views of launch from the cameras at the pad and on Electron right here on the broadcast. Watching the launch from inside the control room at our integration and control facility will be our range partners in Virginia, NASA and Virginia Space, who own and operate the Mid-Atlantic Regional Spaceport where LC-2 is located. The effort behind our historic first Electron launch from Virginia will bring in a new beginning for commercial space activity at Wallops. Here's more from the partnership's leaders.
This represents a historic moment in our history, in the long and storied history of Wallops, with over 16,000 rocket launches. The Starling launch today represents a new era of resilient and responsive access to space.
That kind of capability, to offer that to our nation, to offer it to the commercial sector, to be able to put satellites into orbit. It's an exciting opportunity for not only the commercial aspect, but also for the nation.
Bringing together NASA's engineering with our autonomous flight termination system, enabling and supporting Rocket Lab and the Electron launch vehicle, along with our partners in Virginia with the Mid-Atlantic Regional Spaceport. The AFTS serves as a springboard for increasing the cadence of launches while providing a safe launch where it doesn't rely on human beings. It reduces costs and then allows us to launch more frequently, increasing our efficiency, not just at Wallops, but at all ranges across the United States.
So flying with AFTS from Wallops opens a whole new capability for rapid response, rapid succession, and lessens the mission time support to spool up for a mission. So we're very excited to demonstrate this here at Wallops for the very first time. Integration effort and all the supporting effort has been a tremendous load of work from the team to make it happen. And we are here. We finally have made it, and very proud of the team for the work they've put together to make AFTS happen.
We are most thrilled that we were actually able to build LC-2 pad. We built it from groundbreaking to full operational status in 11 months. Now to be able to see a rocket actually launch off of the pad upon which we built.
So working here at Wallops with NASA team and Virginia Space team, I feel like it's a unified team. Whether you're wearing a blue shirt or a black shirt or whatever color and whatever lapel pin, we're one unified team.
T-minus 21 minutes and counting on the clock for this Virginia is for Launch Lovers mission. Now, it has been a long time coming to launch Electron from LC-2. As we heard from Virginia Space in that clip, alongside technicians from Mars, we built the pad and its infrastructure in just 11 months back in 2020. But beyond the site build has been the monumental effort to usher in a brand new system for the spaceport for this and all future launches, an autonomous flight termination system, or AFTS. Now, AFTS is a computer-controlled way of making safety decisions for a rocket once it has lifted off the pad. A small box on the rocket is run by software that follows a set of safety rules. If those rules are violated while the rocket is in flight, then the AFTS will quickly end the mission. We designed and built an AFTS system for Electron and have been running it successfully on missions from our launch site in New Zealand for more than 20 missions. On NASA's range at Wallops, though, flight termination has been a traditional human-in-the-loop system. Until today, that is. After more than 20 years of software and algorithm development, NASA and the Department of Defense will today debut their AFTS for an orbital mission at Wallops for the first time. It's a crucial system that will become open to all range users to help bring down range costs, increase launch responsiveness, widen boundary limits for launches, and support multiple launch vehicles from the range. We are thrilled the AFTS can now be in use not just at Wallops, but across all NASA ranges, and proud to have partnered with NASA and the DoD to debut AFTS with Electron for tonight's mission. To give you a bit of an overview of the mission, in the next 15 minutes or so, Electron will ignite its 9 Rutherford engines and lift off that pad at T0. Now, once we have cleared the pad, it will be a relatively quick ride to space today for Hawkeye 360 satellites, from ground to on orbit in space in under 60 minutes, in fact. Within 1 minute, the rocket will exceed the speed of sound at Mach 1 to become supersonic, traveling at speeds of more than 768 miles per hour or 1,236 kilometers per hour. Around 11 seconds after breaking the sound barrier, Electron will reach max Q. Now, as the rocket travels, it experiences 3 forces: gravity downward, thrust upward, and then atmospheric drag. Now, the apex of all 3 is the max Q pressure point, or what we call when the rocket experiences maximum dynamic pressure. When our operators call that Electron has cleared max Q, they're saying that the rocket has come through the most amount of mechanical pressure it will experience on the mission. A sense of relief for our operators and the reason for why it's highlighted as a launch milestone. Just over a minute later from then, the engines on Electron's first stage will shut down, an action we call MECO, or main engine cutoff. Now, 3 seconds later, the first stage separates from the second stage, and then 3 seconds after that, the engine on the second stage of the rocket lights up and the mission carries on. By this point, Electron is well into space, and the need to protect the satellites from Earth's atmosphere no longer exists. So the rocket sheds the protective fairing, or the rocket nose cone, to lose the dead weight. That fairing jettison milestone occurs around 3 minutes after launch.
Electron's second stage carries on with the mission until it almost drains the batteries that are powering its Rutherford engine. It won't have reached the mission's orbital altitude yet, so to keep going, the second stage switches to a fresh set of engine batteries. This is an action unique to Electron because it was the world's first rocket to use electric pump-fed engines to get to orbit. Battery hot swap, as we call it, will happen around T plus 6 minutes and 45 seconds into the mission. After that, we'll have our second set of engine cutoffs and stage separations. This time between the second stage and the third stage at around 9 minutes into launch. Following these actions, it's a bit of a wait to complete the mission while the third stage, carrying the satellites, completes its first pass of Earth. Once it returns to the highest point of its elliptical orbit, the engine on the third stage lights up to move the stage and the satellites into a circular orbit. From there, the payloads can be safely deployed into their circular orbit, and once that happens, it's mission success for Rocket Lab and the start of operations in space for Hawkeye 360.
Thanks, Jane. We have now only 16 minutes and counting until the launch of Virginia is for launch lovers. The Hawkeye 360 team are ready and waiting as our launch team makes their way through the count. The final gate to pass will be the go, no-go poll to check in on everyone's status and readiness for launch. That's coming up at the T-minus 12-minute point, and we'll bring up the audio channels and camera feeds into our control rooms while we listen in. But while we wait for that clock to run down, Jane and I will take you through each of our operators as you see them on screen and where they are on console for today's mission. We'll start with Rocket Lab's Integration and Control Facility located here at Wallops. Along the front row, closest to the screens, we have NASA, Mars, and our launch regulator, the Federal Aviation Administration. They'll be providing ground safety, range safety, system safety, and weather monitoring for the launch. At the end of the row is our ICE operator managing instrumentation and control engineering. Behind them, in the middle row, is Majority Rocket Lab with 2 Mars operators in the mix. On one end are our avionics engineers who are monitoring all of the rocket's electrical systems. In the middle are our ground control engineers responsible for the systems at the pad that support launch, like power generation and communications. Our operator managing the propellant loading system for Electron sits in the middle. In the back row is mission management, our IT support engineer, our vehicle control specialist called VCON, and the engineer called Stage, who has eyes on the health of the rocket's engines and who watches over Electron's propellant tanks pressures, fuel usage, engine ignition, and firing. Next to her is our launch director for the mission, Michael Pearson, who leads all of the operators for this mission and who has overall responsibility for the safety and the success of the launch. Next to him is his direct support for the launch director role. And finally, we have VP of Launch, Sean DeMello, offering executive support.
And over at our Global Mission Control Center in Auckland, New Zealand, we also have operators working remotely who don't need to be on site here at Wallops, and other engineers in a supporting position on Shadow Watch. At the front is our RF or radio frequency engineer, looking after the communication systems between Electron and our ground stations around the world. Flight analysts are positioned on the right at the end of the middle row, watching over the mission's trajectory and making sure it's within bounds of our range and mission safety criteria. Engineers supporting our stage and VCON operators in Virginia are sitting in the middle. And at the other end are our guidance, navigation, and control operators who monitor Electron's navigational systems and guidance software and who make the call on the position of Electron's first, second, and third stages in space. At the back, we have ComOps looking after all data, voice, and video communication systems for launch. And finally, Rocket Lab's Launch Safety Officer. All right, T-minus 13 minutes and counting, and we're coming up on that final go, no-go poll scheduled for T-minus 12 minutes. Let's bring up the comms channels and hear from Launch Director Michael Pearson and the operators to see how we're tracking as we get closer to that T0 time at 6 p.m. Eastern.
All stations LD on countdown, proceeding with the final poll for launch, go, no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
VCON.
VCON is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
Mars CE.
Mars CE is go.
Mars Ops.
Mars Ops is go.
Mars 1. Didn't copy Mars 1. Copy Mars 1, go. NASA GSO.
GSO go.
NASA RSO.
RSO is go.
MM.
is go.
LD SUP.
LD SUP is go.
NASA TD.
NASA TD is go.
Okay, the go, no-go sequence is complete. We are T-minus 10 minutes and 45 seconds and counting.
And we are out of the poll for the countdown to liftoff of Virginia is for launch lovers with Electron from Launch Complex 2. As you can see, the clock is moving with T minus 10 minutes, 27 seconds and counting to liftoff. The T0 liftoff time remains 6 p.m. Eastern Local Time or 2300 UTC. As you heard the team confirm there, all systems are healthy, including the rocket and the Hawkeye 360 satellites inside Electron's fairing, and the launch range is clear and ready to proceed. Our launch operators will now work through their final launch pad and avionics checks. These include igniter and hydraulic pressure checks and switching batteries and radio antennas to high power mode for flight. Then the team will make their way through final launch pad readiness checks, including pulling back the strong back to clear the way for Electron, and the run down to the launch auto sequence that starts at T minus 2 minutes.
Now, as you can see, Rocket Lab's integration and control facility here in Wallops Research Park is home to a mission control center. But as the name suggests, it's also where we carry out the final integration of the Electron rocket before launch. The ICF can process 2 Electron rockets for launch in parallel and support payload integration with dedicated customer clean rooms. The ICF has been a hive of activity in the lead up to this mission, and that is only going to continue with more LC-2 missions booked in the coming year. Earlier in the broadcast, we talked about the efforts of the many partners working together to get Electron off the pad today. But with LC-2 ramping up now and Neutron development well underway, the team here at Rocket Lab in Virginia are the most excited of all. Let's hear from the team about the effort that has gone into getting Electron to the pad.
My name is Aaron Kuipers. I'm the Director of Launch and Test Operations here at LC-2.
Rachel Harley. I'm the LC-2 Office Manager here.
Yeah, I'm Nick Griffin. I'm the Inventory and Logistics Lead.
My name is Michael Pearson. I'm the Manager of the Integrated Operations Team here at Rocket Lab, and I'm the Launch Director for the first launch out of Virginia.
So my role here at LC-2 is to coordinate launch operations with NASA and Virginia Space, making sure that Rocket Lab has the appropriate approvals and support to support Electron launch.
Nothing is ever boring. I get to focus a lot on program management. Every area of the company I pretty much was a part of. It let me really learn about Rocket Lab and everything that we do. I like being able to participate with all the different teams in all the different areas. So I can be talking with somebody in New Zealand and talking with somebody in headquarters. And it's just really great being able to integrate with all the other teams as well.
This mission is obviously the very first one here, and it's the beginning of a long run for Electron and Electron missions. We shortly will follow up with Neutron development, manufacturing right outside Wallops Island Gate, and then build of the Neutron pad here at Wallops. That's coming in the future. I'm very excited about that.
I've always wanted to move to the States. I love the place. The people here are so friendly and helpful, and the atmosphere is pretty electric at the moment. I mean, it's our first launch from US soil, so the local community here has been so supportive, and the team's ready to roll. Yeah.
This community is obviously really special to me. I'm a Tiger from Chincoteague, Virginia. So I did come back here and started working at Rocket Lab 3 years ago. The community itself has always been near and dear to my heart. So Rocket Lab coming into the community, providing education resources, providing jobs, has really meant a lot to me.
This is very surreal. It's been a long ride. Joining Rocket Lab in 2018, when the agreement was signed to launch Electron from LC-2, we built a launch pad in less than a year, had a rocket on the pad shortly after that, and then waiting for support over that time, and now actually seeing it happen is the best feeling in the world.
We're quite lucky with our liftoff time for this mission, so my workday doesn't start till about 8 a.m. Pretty standard workday. Do health checks of the vehicle when we first get on console, make sure that we're happy with all the subsystems. We will put the vehicle vertical, fill it with fuel, we'll fill it with liquid oxygen, and go to space. But to be here in earnest, ready to launch, it's a great feeling. We've got some exciting missions coming here, including the Tropics missions, and
we've got 2 out of LC-2, which is pretty exciting, especially what they're actually going to be achieving, which is monitoring hurricanes and severe weather events across the planet. So That's pretty close to my heart.
Just getting this first mission off is going to be great for us. Being able to see this first inaugural one be successful is just going to be the best feeling. Obviously, after this first launch, our cadence is going to pick up and it's just going to be nonstop crazy, which is always fun.
An extraordinary effort from everyone involved. If you're interested in joining the team here at Wallops or joining any of our other 9 sites around the world, we have a lot of opportunities for you. Head to rocketlabusa.com/careers for more information on how you can join the pioneers in the Rocket Lab team.
One of the next pre-launch milestones you will see on your screen shortly is Electron's strong back retracting and moving out of the way for launch. The strong back is that tall black structure behind the rocket that provides stability while Electron is vertical. It also includes the umbilical cable connected to the rocket from the launch pad that provides electricity, air conditioning, gases, signals and commands to both the rocket and the Hawkeye satellites before launch. Now, while the strong back is moving now to be well out of the way when Electron's engines ignite, the umbilical remains attached right until the last moment in the countdown, releasing automatically just as Electron begins to climb.
We're coming up to T-minus 4 minutes to liftoff. A big moment coming up in the countdown, the switch to the launch auto sequence for Electron at the T-minus 2 minute mark. From here, the flight computer on board the rocket takes over the count as our operators in the ICF keep an eye on the rocket's various readings and levels to make sure all is ready for liftoff. The NASA range officials are also keeping a watchful eye over the launch site and launch corridor for today's mission. They're tracking no issues with range, the weather remains clear, and all surrounding areas are within safety parameters. With LOX loading nearly complete, Electron is almost ready to head to space. Let's hand things over to the team at the ICF and Mission Control and listen in on the last few minutes. We'll be back with you shortly after liftoff.
All stations LD on countdown. From now on, there should be no red flags on your critical LCCs. VCON LD countdown.
LD VCON.
I confirm all expected flight computer as goes are green.
Confirmed.
Lock auto sequence and confirm.
Auto sequence locked.
Okay, all stations, we are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
Vehicles on internal power. AFTS is green and enabled for flight.
Transitioning logs system into recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 are pressed for flight.
High flow engine purge enabled. Deluge is active.
T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
Electron
Beginning
the pad,
pushover.
saving ground systems.
Stage 1 propulsion is nominal.
And liftoff of Electron from Launch Complex 2, leaving US soil for the first time and on its way to space up and over the Atlantic Ocean. All 9 Rutherford engines on Electron's first stage now propelling the rocket at more than 700 kilometers an hour. We are hearing good calls from the teams in Virginia and Rocket Lab Mission Control. A clean ascent for Electron, now nearly a minute into flight. You are looking at 56,000 pounds of maximum thrust from those stage 1 engines, but soon they'll be throttling down to support that pass to the maximum aerodynamic pressure point.
Cleared max Q.
There is the call out. Electron has cleared that first milestone and is continuing nominally. The 9 Rutherford engines on the first stage are throttling back up, and all looks nominal for propulsion there. We are now at 1 minute and 32 seconds into flight, with Electron moving at speeds of nearly more than 3,000 kilometers an hour now.
The next major milestone will be those Rutherford engines on the first stage shutting off completely, expected to occur at around T-minutes 26 seconds into flight. That will happen just before separation of the first and second stages, which then allows the Rutherford engine on the second stage to fire up and continue with the mission to low Earth orbit. The events are called out from Mission Control as MECO, stage separation, and stage 2 engine ignition. Meanwhile, those 9 Rutherford engines are continuing to propel Electron at more than 6,000 kilometers per hour. 2 minutes and 10 seconds into flight of Virginia is for launch lovers.
MECO confirm.
Stage separation successful.
Stage 2 ignition.
Excellent news there from our launch operators. Electron has had a successful MECO, stage separation, and stage 2 ignition. The next milestone will be separation of the rocket's fairing. We do this to lose unnecessary weight once Electron is through the Earth's atmosphere.
Fairing jettison succeeded.
And as we saw from Electron's onboard camera and heard from Mission Control, the rocket's fairing has successfully separated and fallen away, exposing the Hawkeye 360 satellites to space on their way to low Earth orbit. Our first launch from US soil is going great so far.
Guidance is nominal.
Stage 2 propulsion, holding nominal.
Coming up on 4 minutes into flight of Virginia is for launch lovers, our 33rd Electron mission. The rocket's second stage is now reaching speeds of more than 9,000 kilometers an hour, powered solely by a single space-optimized Rutherford engine. The second stage will take the payload to the height of the mission's orbital altitude before it separates with the kick stage, which will carry on to insert the mission into a circular orbit. Before that, we'll have a few more mission milestones to complete, including a swap of the batteries for the second stage engine shutdown, and then final stage separation. Those events are coming up at around the 6 and 9 minute marks into launch.
Checking in on the clock, and we are just about T+5 minutes into the mission. Hearing nominal calls here from our launch operators in Mission Control in Virginia and Auckland. The second stage Rutherford engine is putting out a maximum of 5,800 pounds of thrust on its way to delivering our customers' payloads to orbit. At liftoff, the rocket weighed about 13 metric tons altogether. But since it's shed its first stage that stored the majority of the mission's propellant, along with 9 of those Rutherford engine, Electron is down to 1/5 of its liftoff mass, enabling that second stage engine to propel Electron past 11,000 kilometers an hour.
We are coming up to our next event in the launch timeline, what we call the battery hot swap. This occurs on the second stage of Electron for the Rutherford engine, which switches over to a new set of batteries to power its electric pumps once the first pair are almost out of energy. Once the swap is made, the old batteries fall away from Electron, and sometimes we see those shiny silver packs on the screen as they go. So let's keep our eyes on the screen and listen in for the call that battery hot swap has occurred.
Throttling down.
Hot swap successful.
Battery jettison confirmed.
Our
AFTS
vehicle
is
control
saved.
operator there reporting that the battery hot swap was successful, and
Guidance
so
is nominal,
continues
2
our
minutes remaining.
Virginia is for launch lovers mission. The second
Stage two
stage
propulsion
Rutherford
still
engine
holding
is firing nominally and propelling Electron past 16,000 kilometers per hour, with that new high voltage battery discharge holding nominal. That second stage and the Hawkeye 360 satellites are now at an altitude exceeding 300 kilometers. Electron will continue with this ascent for the next 2.5 minutes until we come up on some of our last actions to complete this mission for Hawkeye 360. They include the shutdown of the
HVV
second
battery
stage
discharge
engine,
holding nominal.
followed by separation of the kick stage carrying the payloads so that it can begin its first orbit of Earth before our scheduled payload deployment, expected at around 57 minutes and 18 seconds into flight.
While we're in the second stage burn, let's take a quick look back at the mission so far. So Electron lifted off the pad at 2300 UTC and performed a smooth first stage burn. Our first stage separation events were effortless, as well as the light up of the second stage engine in space to carry on with the mission. You can see it there, moving the mission along at speeds of more than 21,000 kilometers per hour. Hawkeye's payloads will be deployed to a
Stage two
550
propulsion still
kilometer
holding
orbit.
nominal.
So with Electron now past 328 kilometers altitude, we have another
Entered burnout detect
200
mode.
or so kilometers to go until that final phase of the mission.
Guidance is in terminal, 22 seconds remaining.
SICO confirm.
Stage 3 separation confirmed. Nominal transfer orbit achieved.
And that is SICO and stage separation confirmed. Deployment of the Hawkeye 360 payloads to low Earth orbit is now a step closer with the shutdown of that final Rutherford engine and release of the kick stage into its first
Great job on the
grazing
nominal
path of
orbit,
Earth.
everyone.
The kick stage separated into an elliptical orbit of Earth and will take the next 43 minutes or so to bring itself back around to the mission's nominal altitude of 550 kilometers. As it comes back close to that altitude, the engine on our kick stage called Curie will light up and propel the kick stage and the payloads into a circular orbit at that same 550 kilometer altitude. Once it's on the right path, the kick stage will deploy the payloads, Hawkeye 360 can begin operations of their spacecraft, and our role in this mission will be complete.
We'll come back to those final moments when they're due at around the T+50 minute mark. But for now, we'll take a break on the broadcast and we'll be back with you ahead of payload deployment. So we'll see you here soon. Hello and welcome back to the broadcast of Rocket Lab's 33rd Electron mission. Virginia is for launch lovers. We have had our first successful launch from our pad on Wallops Island, Virginia, marking Electron's first launch from American soil at 6 p.m. Eastern Time or 2300 UTC. From there, we successfully made our way through all of the usual launch events, including passing through Max Q, engine shutdown on the first stage, stage separation, and startup of the Rutherford engine on the second stage, and then a repeat performance of those actions, but with our second and third stages to bring us now to these last moments in the mission. That third stage, carrying the payload for today's mission for Hawkeye 360, has completed its first pass in an elliptical orbit of Earth, and we're now waiting for its Curie engine to ignite and position the stage in a circular orbit so the satellites can be deployed to their new home. The call we're waiting to hear from our stage operator in mission control is that the ignition of that Curie engine has happened. Now that is coming up shortly, so we're going to switch over to the nets to listen in.
Now at this point in the count, the Curie engine on the kick stage has ignited and is now boosting the stage and the satellites into that circular 550 kilometer orbit. The engine will continue burning for about 60 seconds when the operator will report Curie engine cutoff has been confirmed. We'll then have the simultaneous deployment of the 3 satellites in Hawkeye's cluster. Very soon, we should receive that confirmation that the Curie engine on the kick stage has shut down, which will signal the deployment of those Hawkeye satellites. Let's jump onto the nets now and wait for that call. Just jumping back here to let you know that what we're waiting for is for data to be received from a tracking station to confirm those actions have occurred in the mission. So again, we're just waiting to get that data back, the telemetry back from the tracking station, and as soon as we have it, we'll hear those calls through mission control.
Just to confirm again, we're waiting to receive that telemetry from the tracking station, and once we have that data, we'll hear those calls from our mission control operators. In fact, we're going to leave up the audio channels from mission control so that as soon as they receive that confirmation, we'll hear it, and you'll hear it too, live on the stream.
Now, Electron communicates with ground stations all over the world. So as we wait to receive the telemetry from this ground station, you'll be waiting for those callouts from Mission Control right here on this broadcast.
LD GSO countdown 1.
GSO LD.
Yes, sir. All roadblocks have been removed and the danger area has been reestablished to the LC-2 fence line.
Copy that. Thank you very much.
LD GSO.
GSO LD.
Going off console.
Copy that. Thank you.
If you're just joining us, we have had a picture-perfect launch here in Virginia, and we are now just waiting news of payload deployment. Our operators have confirmed Electron reached a nominal orbit, and now we are awaiting for the payload deployment from the kick stage to receive that confirmation from telemetry at our ground stations. We're experiencing some slow data connection with the tracking station to confirm that, so this could take a little longer than usual, but we'll stay here with you on the broadcast and give you that information as soon as we have it. Hello, we have a nervous wait here on the webcast as we wait to receive that telemetry confirmation that we have had payload deployment for this mission. We are waiting for that to come through, and as soon as we have it on mission control, we'll share it with you. But just to reiterate, if you've joined us now and you're wondering what we're waiting for, we are waiting for that payload deployment information to come through to the tracking stations.
And for some background information, the commands to ignite and shut off the Curie engine and deploy the spacecraft are preloaded onto Electron prior to liftoff. They're part of the auto sequence that controls the entire launch. So that's all happening right now as we wait for the confirmation of the data to be received from the ground station. Electron communicates with ground stations across the globe, and if we are unable to receive this telemetry from the current ground station pass, we'll just wait until we go over our next ground station pass, which is over the west coast of the United States. So stick with us for confirmation. What a launch we've had today here in Virginia. Electron had a flawless liftoff from NASA Wallops and successfully placed the kick stage in a nominal transfer orbit. Now we're just waiting on that final part of the launch puzzle, the payload deployment. All indications at this stage are that it has taken place as planned, but the ground station charged with confirming this has decided to go offline at just the perfect moment. We're now waiting for that next pass, which is coming up soon.
Hello, welcome back to the live broadcast for our first mission from US soil. Virginia is for launch lovers. After a perfect launch here at NASA Wallops, we are now waiting for those magic words, payloads deployed. Usually we would get this confirmation a little earlier, but it looks like a ground station was not functioning as planned during the kick stage's first pass.
Happily, we're only another 10 minutes or so away from the next ground station, where we hope to connect and get that final confirmation that the payloads have indeed separated from the kick stage as planned. Let's listen in and wait for that.
Payload deployment confirmed.
Well, thank goodness, there we go. That was confirmation of Curie ignition cutoff and deployment of all 3 Hawkeye 360 payloads on our 33rd Electron mission. Congratulations, Hawkeye 360, and welcome to your new home in space, all the way from our new home in Virginia. These satellites will form part of Hawkeye 360's radio frequency detection constellation, able to identify and geolocate sources of radio frequencies from space for communication, navigation, and operations. And today's mission has brought the total number of Hawkeye 360 satellites in space to 15, and these 3 are the first to be deployed into their mid-lateral orbit. This mission also now officially brings the count of satellites deployed by Rocket Lab to 155. Now, 2022 was a milestone year for the entire Rocket Lab team across the world last year. A record number of launches, with 9 for the year, and our first mission off-planet to the moon for NASA with the Capstone mission in June, supporting the Artemis 1 launch with roll-out solar arrays and CubeSat dispensers, and that was just the tip of the iceberg, with this first launch of the new year marking an even bigger 2023. So congratulations to the whole team and to all of our customers and mission partners. We cannot wait to do it bigger and better this year with you.
And a huge thank you to you at home as well for the support and for sticking with us through this broadcast of Rocket Lab's 33rd mission. We're about to end the show here, but remember to follow Rocket Lab's Facebook, Twitter, and Instagram pages for information about our next mission coming up in early 2023. So, for the first time from Launch Complex 2, this is Rocket Lab Mission Control signing off.